Hey there and welcome back to the Code Wrinkles channel for a brand new video, and I really hope that this will be a very fun one because we will look into how we can benchmark our C# code like pros using a library that is called benchmark.net. And from my understanding, or from what I have seen so far, I think that this library is actually right now maybe the only library that helps you to perform reliable benchmarking on which you can really rely when it comes to understanding how your code really performs. And in order to set this up, I have already prepared something here. It's something very basic, but I have created here a very small class that has actually three different way of sorting arrays of numbers. So we have this bubble sort, which performs a bubble sort, of course, on a certain array of numbers. Then we have this insertion sort or insert sort, and you see that it is an insert sort because we are actually starting actually from the second element in the array and then go backwards and do the comparison. And then we have this selection sort where we kind of use this minimum to check or based on it we actually define which of the elements come first and which of the elements come second, while we of course iterate through them. So it's a very simple and standard sorting algorithm. If you want to know more about how these algorithms work, we have three different videos on this channel, one video for each of these sorting algorithms. So I will leave the link to the videos in the description of this one, and you might find also a link to them here somewhere on the upper right corner of this one. Now the idea is very simple. We just want to actually know which sorting algorithm would perform best between these three of them. And just a small heads up, these are really some very basic computer science algorithms that are not used in production ready code, I would say. They are totally not the most performance sorting algorithms. So this already needs to be said. But I guess that they are a very good foundation right now for us to actually understand or see in action how benchmarking works in C# using this library called benchmark.net, and maybe then also draw a first conclusion from a, I would say, very practical example as we want to compare these three different sorting algorithms. So let's get started. Before we actually do anything, we need to add a package here, and let's try to search for benchmark.net, and this should be the package that we need. So we can simply install it in this solution right now. And the package should be installed by now and everything should be fine. Now, in order to set everything up, we will need to create a new class, and I will create here a new class, and I will name this sorting benchmarks. So that would be the name of our class. Now, in this class, I would do some stuff here. So first of all, I will provide here two properties. That would be a public int array, will be called numbers. The idea is that we want to perform the benchmarks for each of the sorting algorithms on exactly the same number set. And that's why we want to have this kind of property. And we will have also a public int sorter, which is the class that contains our sorting algorithms, and that would be it. And now I would like to also create a method that would populate an array, and this method will be called in the constructor. And let me just go here and public, it will return an int array, populate array, let's call it like that. And in this method, I will here insert some code. So what we'll do is very simple things. We have this new random class, and we actually here generate an array of 1,000 numbers, and we also set a random value for each of the number, and each number will be between -100 and until 100. So that's actually the main concept here. And then what we'll do here, very easy, of course, in the constructor, would have numbers equals populate array, and that would do it. And maybe let's also have a sorter, and it would be a new int sorter, and we should be good to go. And now we have to do actually, or to create here some methods for each of the sorting algorithms that we actually want to test or to benchmark. Let's use the correct wording here. So let's have the first one, which would be public it would be void because we don't want to return anything from that. And let's call this bubble sort. And that would be for our bubble sort. Let's just first create all these three. Then it would be the next one, public void. Let's have this insert sort. And then the third one, it's public int selection sort. So that would be the three methods that we have right now. So what we'll do here actually is very, very simple. Here in the first one, we'll have our sorter and we'll call this bubble sort method. In the second one, we'll have our sorter and we will call this insert sort method because this is what we want to do here. And for the third one, we will call this sorter.selection sort because that's what we want to perform here. And that would be all for our class setup. Now, in order to actually tell benchmark.net that, hey, actually, what we want to do is we want to do a benchmark on this method, and on this method. We need to also decorate this methods with an attribute which comes from benchmark.net, which is a benchmark. So the benchmark attribute, and will have to add a reference for that. And of course, here we'll also have to pass in the numbers, of course, that needs to be sorted. And I guess that should be this one. And here for the second, we actually need to do exactly the same thing. So let's have a benchmark here and let's pass the numbers. Okay, so we are good with that. Then on the third one, once again, let's have here a benchmark attribute and then here provide the numbers. And from the setup perspective, actually, we are good to go. So if you want to benchmark a method, you can just simply mark it with this benchmark attribute, and then benchmark.net will know exactly what benchmark it needs to perform. Now, I see that we still have some errors here, and I'm not sure exactly where. Let's go here and see. Okay, what's missing? Make method return void. Okay, I'm really not sure why I did write integer because yeah, that's actually what I want. It's void. I just want to run this sort and that's it. And I want benchmark.net to perform a benchmark on this type of sorting methods. And that would be it from what we need to set up. Now, the only thing that we need to do here, as we are in a console application. And by the way, whenever actually you want to perform benchmarks, you actually need to add a console application to your specific project and then add the different benchmark classes and mark methods with benchmark for the methods that you actually want to perform benchmarking on. And of course, you need to wire up everything in this console application program.cs class, which is kind of like the startup or like the entry point here in our console application. And by the way, this is a .NET Core application that runs on .NET 6, but benchmark.net actually works also with previous versions of .NET Core, and it also works with .NET Framework, and it works even with Mono, I guess, and with few other platforms. Now, the only thing that we would need to do here, and that's actually very, very easy, we would actually need to instruct benchmark.net that, hey, I want you to run some benchmarks. And they would also provide us a summary. I guess we will not look into what exactly that summary contains, but let's use this benchmark runner. So benchmark.net comes with this class that is called benchmark runner, and then we can say run. And here we can provide a type or the assembly where benchmark.net should look after benchmarks. So we will say here, for instance, that we want the program class and we want to get the assembly for that program class. But there is also another way that you could run these benchmarks, and this would be, for instance, by not providing here an assembly, but using here a generic type parameter, and our class is called sorting benchmarks. So that should also run as well and should return us some very, very nice results. And that's mostly it. But there is one more very important detail that we have to take into consideration when it comes to running benchmarks with benchmark.net, is that we always need to run them actually in a release configuration. So we can't run benchmark.net in a debug configuration because it will throw an error. The idea behind it is that when we do benchmarking, we really want to perform those benchmark as close as possible to what we would have in a regular running or a production application. And that would be, of course, that we run it in the release configuration, because the debug configuration adds a lot of stuff that actually is there for debugging purposes and that we really don't need once the application runs for good, let's say. So very important, we have to change this run to not be a debug but to be a release. So that's a very important thing. And I'm doing Rider, or I'm using Rider to create this very basic demo, but you could of course use Visual Studio Code or Visual Studio. The only thing is just be careful that you really need to run this application in release mode. And yeah, that's it. Let's run it. And while the application runs, because it takes a while until benchmark.net performs all the benchmarking. Right now we are doing actually sorting on arrays with, I guess, 10,000 elements, if I'm not wrong. And the idea is that this benchmarking process is fairly complex when it comes to how it actually works, because it actually creates a certain environment, it creates a certain job, it actually runs some workup or some warm-up runs of those methods. It then trims things to create an environment that would be as close as possible to really just running your code and actually measuring the execution time of just your code and nothing else. That's why each method, for instance, or each run is actually, or each iteration of each method that you want to benchmark is actually run in a separate process to make sure that it's actually not affected by the garbage collector that might collect some garbage from other methods or things similar to that. So that's why actually everything is running totally isolated. And you see here in the console, it really performs some very important work. And I would assume just using the stopwatch, for instance, one thing that I usually also did a lot until I stumbled upon this benchmark.net library, it's far better than that, because it really tries to measure as close as possible to what exactly the execution time of your code and only your code is. And we see that right now it has ended. So we have here this run is over, and we see here also a legend. But let's first of all just take a very brief look into results. So we see here that this bubble sort, this took actually a mean time of 1000 and almost 1250. This would be microseconds. So actually less than a nanosecond, that would be microseconds. Then the insert sort, it takes then 723 microseconds, and selection sort actually uses or takes here only 622. And this means, at least from this very basic benchmark that we have done, it means actually that here this selection sort seems to be the most performant of these three algorithms. Now, there is one other thing that I would like to show you, because usually when you are benchmarking your code, you first of all probably will look for execution time or execution speed of your methods. How long does it take, for instance, for my method to execute? That's really a very important point, and we are all actually looking into that when trying to optimize the software that we are writing. But there is another very important thing actually that we have to always counterbalance the performance with, and that one is the memory allocation. And memory allocation, well, of course, you can think of, and if you really know exactly how C# and .NET work and how the garbage collector works and how everything is set up here, you could probably already have an idea of what gets allocated and what not. However, you can have a much clearer idea if you just use another attribute actually on this class where you have your benchmarks. And this one would be the memory diagnoser. And that's actually very cool, because when we run the benchmarks this time, what will happen is that we will also get some results that will also show us what memory does get allocated for each of the methods. And let's run the benchmarks again and just give it a few seconds and see exactly how it will happen. And we're still doing this, I guess, with 1,000 or I guess 10,000 numbers that we have in a certain array and that we actually want to benchmark. Now, as benchmark.net performs the work, there are also some other things that I would like to briefly talk about with you. So first of all, it's very important to note that here we have in this sorting benchmarks, we have this constructor. And in this constructor, we have actually implemented some logic. So first of all, we generate the array. And of course, we also instantiate an object of type sorter that contains this bubble sort, insert sort, and selection sort methods. Now, the idea is that when benchmark.net sets up a benchmark runner, it goes to a process that kind of like harnesses and creates everything around that is needed to actually run this. And it uses a reflection to do that. But during this harness process, it will actually create an instance of this class that you specify here. So this means that when it creates an instance of this class, it will actually enter here the constructor, of course, and then we will populate our array with numbers, which is what we actually expect. Now, the idea is that no matter how many methods you have here, this constructor gets called only once, because the process for benchmark.net is very simple. It first actually builds everything around that it needs for those benchmarks. But once everything is actually there and built for your benchmarks, it actually just runs your benchmarks, and that's it. And that's why actually it is possible for us that in this very standard parameterless constructor, we can then perform some logic here. However, since benchmark.net is using reflection to do that, of course, we can't really provide here also constructors with type or with parameters. There might be other more sophisticated strategies or workaround with benchmark.net using param values and things similar to that. And probably we'll cover that in some other videos that would kind of like help you a little bit to actually get started with that. But the idea is that you can use, once again, this standard default constructor, but you can't really provide a custom constructor in which you also specify some incoming parameters. And now also this benchmark run has ended. And if we can see here, it has also allocated, or it has added actually here a new column here in this table, which is called allocated. And to be sure, I'm not sure exactly why actually it did allocate 1 byte. It's however very, very small. So I'm not sure exactly why the allocation was done, but it could be that this is also part of the error or standard deviation, because what we do actually, we just have an array of numbers and we perform stuff on that array of numbers. And we have only an int value that we specify here in our int sorter. So if we can take a look at that here, we see that we always have this int here, which is which always goes on the stack because it is part of the method, so it doesn't get boxed. So I'm really not sure why exactly we have this this allocation of 1 byte for 2 of these methods. When I did run a similar thing, or very, very similar or close to what we have right now, for instance, when I was preparing this video, actually, I was getting, for instance, no allocation for all 3 of these methods. And I guess for one of the runs, I was getting an allocation only for the insertion sort, but it was kind of like always 1 byte. However, let's not really stick here with the values, because what we always have to look into whenever we perform this benchmark is actually trends and how things actually are related one to the other. Because for instance, you could have some methods that might be, for instance, very quick like this one, but if they allocate a lot of memory to perform their job, then you might even maybe think or take a method or a way of writing a method that is not that fast, but that it allocates less. So as I say, always in software engineering and software development, whatever we do is actually a negotiation, a trade-off between speed and what we actually allocate, the memory consumption of our application. So that's why using also the memory diagnoser is very important, because speed itself or execution speed itself is just one part of the story, is not the entire story. And whenever we actually try to make decisions, we should always try to also keep track of the speed of the execution time, but also of the memory allocation, because that would be actually very, very nice. And here in the results, we have some information like a legend of what each of these things actually means. What is the mean, what is the error, what is the standard deviation, what is the median, what is allocated, and so on. And we see that here US, this is a microsecond, just like I told you before. And that's basically it. However, there is one other thing that I would like to show you. And if I click here, right click on this solution, and if I go to show in Explorer, that should open an Explorer window, and let's bring it here on this window just right now. And here we see that, okay, we have this application. And if we go to bin release and .NET 6, we see that we have here this benchmark.NET artifacts. So if we go here, we see that we have some results. And we have here, for instance, an HTML file that will, of course, open on a browser tab. I will bring it over here. So it's like that. And these are virtually also the results that we have seen in the console, but you get here this very, very nice template. And of course, if we want to have an Excel spreadsheet containing these results, we can open this Excel file. And here in this Excel file, actually, we have a lot of information. So if you want, you can just go through it and take a look and see exactly what is provided and what not. But it's actually very, very, very complex. But the idea is that always the benchmark.net also writes some artifacts, and you might always be able to check them out. Okay, so our conclusion here from this one is that, okay, we have seen that using benchmark.net is very, very easy, and it's actually very powerful. It's, if you think about this proportion on how easy it is to use and how powerful it really is, and how helpful it is when it comes when it comes to helping you to understand exactly how your code performs. I guess that you will probably fall in love with this benchmarking library, as I did, of course. And as a technical conclusion to this, when it comes to comparing this very basic or standard and simple sorting algorithms on arrays, our conclusion could be that, of course, bubble sort, as we would have expected, is the less performant one. Insert sort, it kind of like lies in between, and selection sort is the one that seems to be the fastest right now. So that's kind of it. If you did enjoy this video, then please feel free to share it also with other colleagues or friends, or with whoever you might think would find this video useful, and I will be very much and I will be totally grateful for that. Also, if you didn't subscribe so far to this channel, please subscribe, and also hit the notification bell to actually get informed whenever we post something new, or for instance, when we go live, because we do also a lot of live coding sessions. And yeah, this being said, once again, thank you very, very much for watching. And until the next time, I wish you the very best.